Continuing on with this technique of greatest common factor, next example. We have 15 and 25. 15 is 3 times 5. 25 is 5 times 5. Those are our prime factors. So the greatest common factor in terms of our coefficients will be a 5. Now we have variables. In this example, we have not just x's, but x's and y's. So here for the x, in the first term we have x cubed. In the second term we have x to the 5. So between 3 and 5, it's going to be x to the 3, x cubed, that we can use as our greatest common factor. Now let's take a look at the y variable. We have y squared and we have y cubed. y2, y3 for greatest common factor. It's the y2 that we're able to use. So there is our greatest common factor. Again, our answer is going to be 5x cubed, y squared, the greatest common factor, and then the parentheses, what we have left after the division. So writing down our polynomial, there it is. Now the division, showing that GCF, showing the division we're going to be doing. 15 divided by 5. That gives us 3. Now let's take a look at the x's. X cubed divided by x cubed is just 1. There's no more x's. So there's no x in this term here. Now, y squared divided by y squared, that also is 1. So in this first term, in the parentheses, we do not have any more variables because with the division, they were eliminated. Now we have a minus sign. From the minus sign in our polynomial, 25 divided by 5 is 5. Now let's take a look at the division with the x's. X to the 5 divided by x3, 5 minus 3, that leaves us with x squared. Y to the third divided by y squared, 3 minus 2 is 1, so we're left with 1y. So there is our answer. And again, we could always check by doing the multiplication. 5x cubed times y squared times 3 would give us 3 times 5, the 15, x cubed y squared. And you could continue that if you wanted to, but I know you'll just push the button on my math lab to have it check it for you. Okay, this fourth example here, looking at our coefficients, we have 16, 8, and 4. So this one, I'm not going to look at the prime factors. I'm hoping that you can see that the greatest common factor is going to be 4. That's 16, 8, and 4. All of these are multiples of 4. 4 times 1, 4 times 2, and 4 times 4. So I'm going to take that approach because it is another approach. If you need to, you could break these down into primes and build it the way we did in this example here. Now we have to take a look at our variables. I'm seeing x's and y's again. So for the x's, we have x4, x cubed, and x squared. So we can take the smallest exponent, 4x squared, to use as our greatest common factor. Now looking at the y's, y5, y4, and y cubed, it would be y cubed, the smallest exponent that we're able to use in our greatest common factor. So we've identified our greatest common factor, 4x squared, y cubed. And now the parentheses of what we have left after the division. So as I've done in the other examples, I'm going to rewrite the original polynomial there. and I'm going to show the division with our GCF. Okay, now to do the division. 16 divided by 4 is 4 with the coefficients. X4 divided by x squared is x squared. Y to the 5 divided by y to the third would be y squared. Now minus, moving to the next term, x divided by 4 is 2. X to the third divided by x squared, 3 minus 2 is 1, so it would be x. And then y4 divided by y3, 4 minus 3 is 1, so it would be y to the first. And we're done with the second term. Moving on to the third term, 4 divided by 4 is 1. X squared divided by x squared is 1. And y cubed divided by y cubed is 1. So this last term inside the parentheses is just 1. Let's take a look at this situation again. If you take a look for a moment here, our GCF is the exact same information as our third term, as our last term. I'm going to repeat that. Our greatest common factor is exactly the same as one of our terms. Whenever we have that situation where our greatest common factor is exactly one of the terms, it will always, always, always be a 1. And that is very important that you do not forget that 1, because if you do, if we didn't have that there, when we did this multiplication, this times this will give us the first term. This times this will give us the second term, but we will have lost the third term there, because 4x squared times y cubed times the 1 gives us this last term of the 4x cubed. Why do I keep saying x cubed? 4x squared y cubed. So when you have a term that is the same as the GCF, you are always going to have a 1 sitting there after you've done your factoring. And this will be our answer.